solve a problem, a coding challenge basically. So the question is, given a list of sorted integers, you're supposed to remove the duplicates. So suppose you're given this list with 1, 1, 2, 2, 3, and then the output has to be 1, 2, 3. So unlike most of the coding challenges, what you want to do is go through all the possible solutions, and then design an efficient solution before you start coding it. So let's see how we can solve this problem. So first thing that we should note is that the list of integers are sorted, and then we need to remove the duplicates. So one idea would be to look at Eden. So let's say we have the list 1, 1, 2, 2, 3. So we start with an output list which is empty, and then each time we see an element we add it to this list, and if we keep seeing the same element then we don't add it, and if we see a new element then we add 2, and then if we keep seeing 2 again we don't add it, then we see a different element we add 3. And this is one way of doing it. If you look at the time and the space complexity, then since you're looping over each element once in the original array, so this is an order n algorithm, and the number of elements, the extra space that you're using is, let's say if you had like n distinct elements, then you would end up using order n space. Now the question is, can we do better than this? So in terms of time, we cannot do better than that because we would have to look at each of these elements. In terms of space, can we do without allocating extra space? As in, can we do in place and return a new length of the array? So for example, if we could do in place removal of duplicates and return the new length of the array. So let's try to explore this idea where we have an order n time complexity algorithm and order 1 space complexity. So the way we would do it is perhaps, so let's look at the input array again. So let's look at the first element. So the first element is 1. So you move on to the next element, which is 1 again. Now you look at the next element, which is 2, and you know that you have already seen 1. So perhaps what you could do right now is swap 2 and 1. And then now you see 2 again. And you have seen 2, 1 and 2 before, so you go on to the next element, which is 3. And what you should be doing is perhaps swapping 1 and 3 over here. And then you would have 3 and 1 here. Now note that till here, you have a new length and all the elements are unique. So if you just return a length of 3, then your elements in the length up to length 3 are basically distinct elements. So let's try to devise an algorithm for doing this. So let's take another example. So here, you start with 1. So your current element is 1. And then you look at the next element, which is 1 again. So you keep moving forward till you see the same element. Now when you see a different element, and you remember the first time you saw a duplicate element, so the current index swap, let's call it swap index, is equal to, so when you see the same element again, so I saw same element again, so I would set the current swap index to be 1. And now I see the same element again, so I don't do anything, so my current element is still 1. And my current swap index is 1 again. Now I see 2. So this is different than the current element, so I do current element equal to 2. And what I do is basically swap the elements at index I and current swap index. So if I swap 2 and 1, so this becomes 1, this becomes 2. And you would increment the swap index to be the next element, so swap index becomes plus equal to 1. And now you're looking at the next element, which is 2 again. So your current element is 2 and your swap index becomes 2 as well. So now you saw the same element again, so you move on to the next element, so which is 3. Now it is different than the current element, so you set the current element to be 3. And remember, the current swap index is 2, so you swap 3 and the element at index 2, which is 1. And now you've reached the end of the and swap index now becomes 3, right? So, and in the end, you just return the swap index. So now this is the length, the swap index is 3, which is the length of the new array. So now you have an algorithm which does in-place removal of duplicates. Now let's try to quickly code this idea. Now since we have devised the solution, let's quickly code it. Let's call it remove duplicates. You're given an array. And then you need the current element, so you start with the current element, say array 0. You start with the swap index. Now this is interesting. Now what if all the elements were distinct? So basically your swap index would be so if all the elements were distinct, let's look at that case. So basically in this current element would be this, and your swap index would be nothing, you would never have a legitimate swap index. So let's assign it -1. Now for I in range 1 to len of array, what you're doing is if of I is not equal to current element, and swap index is greater than -1, then basically you're swapping the element at swap index and I, and also incrementing swap index plus equal to 1. Now the other case is that the array is equal elif array is equal to current element, then you keep incrementing I, right? Let's see. You keep incrementing I till you see a different element. Sorry, let's say that this is incorrect. So if your current element is not equal to this, then you set the current element equal to array I. And now if the swap index is greater than -1, then you swap the elements, and then you increment the swap index. Else, if it is equal, else if Now let's try to do a dry run of this. So let's take this example. So we started 1, the current element is 1, the swap index is -1. Now we look at the next element, which is 1, and the current swap element, if it is equal, and the swap index is -1, it becomes 1, and then we see the element again, do nothing. Now we see a different element, which is 2. So the current element becomes 2, and if the swap index is greater than -1, which is the case, then we swap 2 and the element at the index 1 and increment the swap index. Now we see 2 again. We do nothing. We see 3, which is not equal, so our current element becomes 3. And since the swap index is greater than -1, we swap the elements. So yeah, this should work. So yeah, this is an interesting problem, and if you liked the solution, please hit a like and subscribe.